You need read. 62?
Okay. So last time we were looking at tangent lines. So that's a situation where we have a quadratic and we have a line here and it meets exactly one time, and we compared that to secant lines, which would be something like this. It meets two points. Okay. Now, before we get started, just a kind of a concept. We can imagine that the secant is roughly the same as the tangent if the 2 points are actually quite close together. So if we have a picture like this, where the 2 points are actually rather close together, then I think we can all appreciate that line is not going to be much different to the actual tangent line. Okay, so secants and tangents can nearly be considered the same if the 2 points are almost together as 1 point. Now that's actually, although simple enough, it's actually a very important idea for this lesson. So I'll just give you a minute to write these little bit of notes down, and then we'll continue. Got that? Yeah, kinda. We're continuing from the previous, yeah. Okay, got that written down? Okay, so, scroll down. Yep. Okay, scrolling down. So, some definition. So the slope or the gradient of the secant, we write it as this: delta y, delta x. Yeah. The same thing, y2 minus y1 over x2 minus x1. But this one is a little bit different because the points are quite close together. So what we'll do, we'll imagine we have a situation like this. We have a point here, which I'll just call xy, and then a little bit to the right of it, only a small distance, we'll call that distance h, which is quite small. We'll mark off another point. So our first point is xy, and our second point is x plus h, and then f of x plus h, where this is fx. Huh? Yeah, which is y. Just y at that value. So as you said, Amjad, yes, this is y2 minus y1 over x2 minus x1. And for our example, that will be fx plus h. Now that y actually, let me just change instead into fx, be a little bit more convenient. So fx plus h minus fx over x plus h minus x. So that equals fx plus h minus fx all over h. In fact, that is the formula to calculate the slope of the secant at the point x. The only requirement I have for this formula is that h is you have to use some small value here for h. The smaller your choice for h, the closer the 2 points are to each other. Okay, so for some small value of h, we can get the slope of the secant. Yeah.
At what point would you consider like the value of h to be?
Yeah, like there's no rule for this. Certainly less than 1. Certainly less than 1. So in the exam, typical value, acceptable value would be 0.1. However, often you simply leave h in the formula and let the person decide whatever value of h they want. But for some reason, if you had to pick a h, which has happened once or twice, 0.1 is a good small value. You don't want to pick a value so small that your calculator won't take it. And you certainly don't want to pick a value too big. So 0.1 is usually okay. Okay. Shall we scroll down, or do you need a minute? Does this formula look familiar to anybody?
Oh, wait.
There's another way to solve that.
A couple of ways.
Isn't it similar to the formula of the derivative?
Yeah, well, that's what this is leading into, you know. All right, let's continue. Guys, we're continuing, please. Right. So let's have a look at an example to see this in action. So let's imagine, we'll keep it not too difficult. I have a simple quadratic, something like fx equals x squared. Very simple. And let's keep our point rather simple as well. Let's say I'm here at the point x equals 1, and I want the slope of the secant. So we need to have 2 points to make a secant. So we put our neighbouring point beside it, and the distance between them, what do we call that? Something small, but we'll just call it h distance between them. Okay, so let's see, there's our secant line. And let's calculate the slope of this. So according to our formula, it's fx plus h minus fx over h. So in this case, that will be x plus h squared minus x squared over h. That will be x squared plus 2xh plus h squared minus x squared over h. Now what's nice is that cancels with that. So you're left with 2xh plus h squared over h. That and that all cancel. So you're left with 2x plus h. Now we know what the x is. What's the x here in this one?
1.
We said to choose 1. So the answer here would be 2 plus h. Yeah? Where h is some small number of our choice. So for example, if we choose to use h equals 0.1, then the answer here is the slope is 2.1.
But shouldn't you provide like a range?
No. Like normally in maths, you would actually leave the answer like this. So you're saying that the slope of the secant is equal to 2 plus some small number of your choice. And usually if you want to make it clear to the reader, you're talking about the slope when x is equal to 1. What's very common is this notation. Hang on. You would write a vertical line with x equals 1 at the bottom. So what you're telling the reader is the slope of the secant when x is 1 is equal to 2 plus a small number. Yeah. Oh no, it didn't disappear. We put in the value of 1. Yeah, so at the beginning we said the slope of the secant at 1. Yeah. Okay.
So the slope is 2.1?
Well, whatever. Yeah, if you choose 0.1 or 2.01. And so on. Okay. Did you write that down? Yeah. Okay. Now let's just get thinking about the next thing. Okay. So we know that a secant crosses the curve twice, but we don't really care about secants because they're uninteresting and boring. We are really interested in finding tangents. They're much more interesting and important. So we said that a tangent is roughly the same as a secant if the 2 points are close together. And the closer they are, the better. The more like a tangent it is. So if we continue this logic, if we make them closer and closer together, what's happening to our choice of h? It's smaller and smaller. Now let's make a leap here. If we want those 2 points to become 1 point, and so we have a tangent, then what has happened to h? It's become 0. So then we can actually conclude from this answer that the slope of the tangent, in this particular case, is 2. If we continue our logic. Yeah. Yeah?
But if you do that from the start, you need to...
We can't, because we can't divide by 0. So we can't actually do this at the start, because here h can't be 0. Right? Because we're dividing by 0.
But
However, there's no reason h can't be 0 here. Huh? Can h be 0 here?
Yeah.
Yeah.
I'm probably mixing,
Here?
No.
No. So we have to wait a little bit. Yeah?
I'm probably mixing something up with something else, but I remember somewhere where like if it's over 0 then it's approaching 1, so the answer would be 1.
Yeah, you're mixing up with something else, but I don't know what. But not here. Not here. Okay. Have we got this? So we can this one is 14 about. Now we can actually put this into a formula. So if you think about it, we said that the secant slope is given by this formula. But the tangent slope is nearly the same thing, except we just have to make one small addition to it. What do we do if we want a tangent? Well, we just saw a moment ago it's something to do with the h. You have to make the h become 0 at the end. So at the very last step, we imagine the h becomes 0, and we've just figured out the tangent slope. So the way we write that in maths, if we want to tell the reader to make the h 0 at the end, we use this symbol here. Limit h to become 0 at the end. Yeah.
And is there a way to do it?
There might be, but this is the most common way to say it. So, the symbol we use for slope of tangent rather than slope of secant is this, dy dx. So this is the formula for the slope of the tangent. And the slope of the tangent is important, so important it's given its own name.
Isn't that derivative?
Yep. Derivative of f is called the slope of the tangent. Yep. Why, what did you think it was? Yeah. The derivative is the slope of the tangent. That is the definition. Amjad, I feel like I'm blowing your mind here or something. What are you
I
thinking?
just realized that it was like, well, delta y over delta x, and it makes sense to get from scaling control of it. Let's go back, okay? From derivative to the slope.
Do you feel like you've been enlightened, is it? Or reached a higher level, is it? Yeah. Yeah. Okay, so to demonstrate this, I want to take an example that we did last time. So, can you just look back and find the example we did where I asked to calculate the slope of the tangent. Remember last time we wanted to calculate the m? Remember that example I did? Yeah, the one I did in class. Can you give me that question again? What was it?
Y equals -x squared
Yeah.
minus 3x plus 4.
Minus 3x plus 4. And x was 0?
Yeah.
And 0 and y was
4.
yeah. Now I'm not interested in finding the line or the c. I just want to find the m. Okay. I just want to find the m. Right. So let me show you how to do that using our new formula from today. So m is the slope of the tangent, which we just said is called the derivative dy dx, and we have a formula for that. It's limit h goes to 0. Fx plus h minus fx over h, whereas this is the fx. Okay, so let's test that out. Equals limit h goes to 0 all over h. Just be careful, x plus h, it's this. It's 9x plus h squared minus 3x plus h plus 4. That's the value at x plus h. Now we have to do minus fx. So that's minus 9x squared plus 3x minus 4. The minus. Right, let's expand. Because it's a minus in the formula. So that will be 9x squared plus 18xh plus 9h squared minus 3x minus 3h plus 4 minus 9x squared plus 3x minus 4. What can I cancel here?
9x squared.
9x squared's gone, is it? 3x? 4? Not yet, because I can't divide by 0.
Divide by 8.
Say again? You really should, but if you want to be lazy, I'll forgive you, but you really should.
Divide by 8.
Is any cleaning up we can do?
Divide by 8.
Yeah, no, anything before that?
Take 3 out maybe? Take 3 and 8 out.
We could take the 3 out. Okay, we'll divide by h, so let me just get rid of that line. So we've cancelled that with that and that goes with that and that. So you're left with 19xh, 9h squared and minus 3h, and we divide by h. So that will leave us with 18x plus 9h minus 3.
Take 3 out.
Yeah, I will leave it there because we'll put the h 0 now, then we'll see what we get. 18x minus 3. Yeah? Now what did I say the x was though?
0.
So if I want dy dx when x is 0, which is the m, that will be minus 3. Now what was the answer we got yesterday? Minus 3. Okay, so you get the same answer.
Where did the plus 9x go?
Ah, remember limit. Yeah. Yeah. From here to here, is it? Yeah. So all that really happened was, at the very beginning I said x is 0. So I didn't sub that in yet. You usually sub it in at the end. So at the very end, all I did was I took x and made it 0. So yeah, 0 minus 3, so that's just minus 3 then. Yeah.
Are we supposed to know all of that? Because I know how to do it in this school stuff.
Yeah, I know, and I know how to do it, and everybody who studied this knows how to do it.
Are we supposed to write all of
Yes, because in the exam they could ask you to do it this way, and if they want you to do it this way, they will say,
But at the same time,
no, I know, but you know, give the people what they want. So if they say, you know, make my martini shaken, not stirred, well, I know it's the same martini, but, you know, still shake it, don't stir it, you know, so, I know, but give the people what they want, you know. So, the name of this whole process, or the name of the formula, this whole process is called the method of first principles. So if they say this in the exam, I'm afraid it can only be this way or no marks. Yep.
What
Exactly.
What if he's so stubborn he doesn't lose money?
That's fine. You know, free country. I mean, if you want to say screw you and your first principles, it's fine. No problem. Yeah. Zoom out. Yeah. Oh.
we're told like to do it in just like
1, 2, 3, 4, 5. It's not the worst. No, but so I've seen it maybe twice.
There's something that I don't understand. When you say I've seen it twice over.
Over 10 years.
That's good.
Yeah, that's good. Yeah. So I mean, it's more likely that you won't get it than that you will get it. Yeah.
Has it been recent?
Yeah.
Yeah, okay, then we get it. Statistically.
This line. Yeah, that's just the formula. So this one here, is it? Yeah. Guys, can you look up? So, just to be clear about how I got this line. Can I zoom in a bit to it? Yeah. Because this one's a bit confusing. What you do is you take this original function here, okay, and you replace the x in it with x plus h. So instead of having 9x squared, you have 9x plus h squared. Instead of 3x, it's 3x plus h. 4 maintains being 4. Okay, so that's this part. Now the next part, fx, simply means the original function. So there are the 3 original parts. Now the reason the signs have changed here is because of the minus in front. So the signs get all flipped around then, yeah. Is that okay for you, Michelle? Are you sure? Yeah.
One, yeah?
No. We haven't talked about that yet. That's the next class. So
So that's what I was mixing things up with.
yes. Okay. Question here? This one here is 24.
how similar is
This is differentiation.
Because it just looks like the same.
It is. Well, I'll come and play a bit more. Guys, you have this. Can I scroll down? Yep. Okay. So look, we've actually, when you think about it, have two methods for finding the slope of the tangent. The method we used yesterday, what did we use to get the m? Like, what was the key step that let us get the m? The discriminant, okay? So you could kind of say yesterday's method, you could call it the method of the discriminant, perhaps. And this is the method of first principles. However, this method has a huge advantage over the method from yesterday. The method from yesterday works only for quadratics, because you only have the discriminant for quadratics. Whereas this method works for every function possible, and that is why it's the definition of derivatives. Okay, so that's why it is. You can as well, actually, yeah. Cubic, yeah, well actually, cubic is what I'll do in the next lesson. I'm still sticking with quadratics. Now the reason I'm doing that is because Amjad, listen to me. Listen, no walla yani tamam. Listen to me, okay? Listening? 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 Yeah? Dagiga? Okay. Right. Now, the reason I'm focusing only on questions with quadratics is because in the exam, they will only ask you to do first principles for quadratics. Okay? So the most difficult example they can give you in the exam is the one I just did, a quadratic. In fact, sometimes they're actually a little bit nicer and they'll just have a short quadratic, you know, something like 2x squared plus 1. Okay, so like it makes it a little bit easier. Okay. Yeah? Yeah, no, I know this. Okay. Let's see. Oh yeah, just a little bit of notation here. So, this, you can also write it like this if you want. Or you could write it like this if you want. Or sometimes you can write it even like this. Or what else? You can write it like this.
Will we be doing practical problems with this?
Yeah. I think I have them all.
What is this? Why was this dot?
The derivative.
I've never seen the
I've
one.
never seen this.
No?
The dot thing.
Try and think if there's anything else.
Why does it have dot?
Just a notation. So look, in the exam, you know, I think they usually stick with this one, and maybe this one, but I don't think I've seen this one in the exam so much. Most of the time, they use this notation. But when I'm doing these questions, I sometimes use this just because it's more convenient and it's quicker. But if you're looking up calculus books, there's many other notations that mean the same thing. There's 1, 2, 3, 4, 5, 6, 7, 8. I can think of at least 9 different symbols to mean derivative. Okay? I just want you to be aware of this if you're looking things up online or in books. These are all the different symbols I can think of. There might even be more, but I don't... yeah, but actually some books could even just write it as the formula, you know. It's like this, but that's going to be very rare. Yeah. Now, what I want you to do, you can get this in the exam, Amjad, using the first principles method. So I do want you to practice a couple of quadratics. And I think it would be good if you did at least one non-quadratic, just in case something catastrophic happened in the exam and you got something that you weren't expecting. So, we'll say...
Sir, another notation is FN.
Oh, thank you, you're right, that's another one. So you could have written it as F1X. Yeah. And sometimes, okay, now just you made me think of two more. They can sometimes use Roman numerals, so F1X, and sometimes a bracket, F1X.
And FN.
Yeah, I'm just keeping it to one derivative, yeah.
The derivative of the derivative. What are we going to find?
That we will discover in a couple more lessons.
Double derivative.
Yeah. But you mean what does it represent?
Yeah.
Yeah, that will be coming shortly. Yeah. Stay tuned next time. Yeah. Okay. Can you do for me now for a few minutes? Yeah. I think you should get these done now. I don't think they'll take you too long, and then we'll go on to Amjad. We will then go on to doing this in one step in the next lesson. But for now, I want you to do 2 ABC. 2 ABC. Question? Here, let me just close this and stop the video first.